this final activity, students will explore another method of making their cars move. They will be balloon-powered cars, just like this. Balloon-powered cars use thrust in the same way that the propeller-powered cars did. The balloon gets smaller and forces air out the back. This air is thrust and pushes the car forward, making it move. After the activity, have students compare and contrast the various ways of making their cars move.
The completed balloon car prototype is shown here. However, students have a lot of freedom in their balloon car designs, so you may choose to not give them the instructions at all and have them design their own balloon cars from scratch. The key to a successful balloon car design is to have a lot of room for the balloon to inflate. The more air you can fit into the balloon, the faster and further your car will go. To power their cars, students will inflate their balloons using an air pump. They must stop inflating when the balloon pushes against the Connect frame. To run their cars, place them on a flat surface and let go. Just like in the previous activities, there are a number of design challenges that you can choose from. You can have the students design their cars for maximum distance, maximum speed, or even maximum efficiency. In this case, efficiency would be the distance that the car travels divided by the number of pumps used to inflate the car. If you have the students measure their car's speed, you can also have them practice unit of measure conversions to convert their speed from inches per second to miles per hour.
In a concluding discussion of this activity, ask your students the same questions you've asked in the last 3 activities. Which designs worked best and why? Which designs had some trouble and why? And finally, how would you improve your design? Remember, engineers can always improve even the best designs. Your students are probably getting very used to these questions by now, so they should be more prepared with answers. Another option for activities 4 and 5 would be to combine the engineering design challenges from both activities into one big engineering design challenge. Student groups would have one more decision to make in terms of creating the fastest car, which would be, do you power it with a rubber band or with a balloon? This extra decision would result in increased creativity, increased variety between the cars, and it would take a little bit more time for the student groups to figure out. Ultimately, this could be a lot of fun and is an option that you can use in your programs. Throughout this module, students have explored ways of making cars move using gravity, rubber band power, and balloon power. At this point, ask the students which one worked best and why. The why shouldn't just be that it moved faster, but really, why do they think it worked best? Similarly, automotive engineers are looking at ways of making much cleaner cars. Cars of the future will be cleaner and more efficient than the gasoline-powered cars of today.